Yes, we are right. Live. Hi everyone, welcome to Kotlin Hyderabad's another episode. Well, you know that since 2017, Java has made two releases for every 6 months, for every year. Right now in 2020, the current Java version is 15. Today, with our talk, we are going to equip you with some of the notable enhancements from Java 8 to 14. Before going to have a talk, let me give a small introduction about our speaker, Chandra. Chandra is a technologist in the financial services industry since 2003. He's in programming with Java since 1998. Being a leader at New York JUG, he has conducted many workshops, Code Katas, and code on core Java features. He's a frequent speaker at many JUGs, technology conferences like CodeOne, GIDS India, Devnexus. He was selected as a Java champion in 2019. Without much late, let me hand over to Chandra. Let him start the presentation. Yeah,
Great.
Chandra, you can start now.
Great. Thank you so much. So I'm going to share my screen real quick. So bear with me. Hello, everyone. Welcome to today's session. My name is Chandra. A very quick introduction about me. You can find more of this on cguntur.me. This is my website, and you'll find an About section there. And you will notice that I'm an avid coffee consumer, and I love spiritualism, photography, space, and I'm a sci-fi geek. I'm a confirmed Saganist. You should look up Carl Sagan if you don't know who he is. And I enjoy content by a few different authors. My motto is Docendo Decimus. You will find that on my, icon as well, or avatar as you call it. And obviously, thanks to Chaitanya, you've already got an introduction about, some of my bio. A few contact information for me are made available as links. My GitHub profile, my speaker deck, Twitter handle, LinkedIn, and Facebook. I'm not much on Facebook, but I just added it because I do broadcast our jog sessions through Facebook. So please feel free to visit any of these if you want to get in touch with me. Also, there is a contact section on my page, which allows you to reach me through the website in case you don't have any of these details. So it is cguntur, which is my first initial, last name, .me, and that's where you can find me on the internet. Great. With that, I'm going to stop with my about, and let's get into the meat of the topic. Today's topic is Java, some notable features and enhancements from 9 to 14. So without further ado, let's get started. I'm going to enter a full screen mode. Hopefully, you should be able to see this real quick. Full screen mode. Great. Chaitanya or Raj, if you could just confirm that you can see the screen.
Yes, Chandra, I can see the screen.
Great. Thank you so much. So let's get started. So what are we going to talk about today? What we will do is we're going to cover modules of Java 9, 10, 11, 12, and so on and so forth. And for each module, there is a little section that I put up there. It's a hashtag. And that is what was the hashtag that was prevalent when that particular release was, made public. So that's what we're going to do. We're going to go into some individual features in more detail, and some will just be listed as other features because we don't have enough time to cover everything together. Great. So let's get started. Java 9. Java 9, as Chaitanya pointed out, was released in 2017. It was released in September of 2017. Java 8 was released in March of 2014, so it was a 3-year gap between these two releases. So Java 9 was huge. It had about 150 new features. It was one of the largest upgrades of Java. And Java 9 also introduced a new format, which I wanted to just touch upon, in that now releases are marked as LTS, long-term support releases, or feature releases, which are shorter-term support releases. An LTS release is an agreed-upon standard by the vendors, right? A consortium of vendors who create Java. Java is not just created at Oracle. There are several vendors who can now produce Java. And all these vendors agree upon certain versions that can be commercially viable and supported for a longer period of time. This is in the best interest of both the developers and the vendors, because once you have certain versions marked as such, it is guaranteed to have lesser experimental features, lesser preview features, and features that can sustain over a long time, right? And then there are feature releases which can introduce new enhancements or changes that are experimental or preview in nature. An experimental feature is something that can be dropped later on, And the preview feature is something that can be either improved or dropped later on, right? So the different formats, and I just want you to be aware of those terminology: an experimental feature and a preview feature as we go along. Certain releases are marked as long-term support releases, and certain others are marked as feature releases. Now, there is no rocket science behind this. Starting Java 9, the thought process was that Java 8 would be considered what is called a long-term support release. And then the subsequent release that would be marked as long-term support was a jump to 11. And why this jump, I don't know. We will cover that in more detail as we go along. But starting 11 onwards, every sixth release, since it is a 6-month cycle, the sixth release would be released after 3 years. So every 3 years, you get a new long-term support version of Java. So if Java 8 was considered long-term support and Java 11 was considered long-term support, the next one would be 17, then 23, 35, etc. So that is the logical progression of Java on the long-term support. The short-term or the feature releases are released on a per 6-month cycle, supported for up to 6 months. And other vendors may choose to support it further, right? It is not like a vendor can just say, okay, the rule is 6 months, so no one will support it after 6 months. It is that the general understanding is that these releases won't be supported for a long time, right? So it depends on the vendor you have chosen. Some vendors may choose to support short-term or feature releases as long as long-term, or may have a different strategy for those. That is something to be aware of. Great. You can find a lot of information about Java 9 on the OpenJDK Java JDK 9 link that is included. And I have about a 75-page presentation on the new features of Java 9. I mean, there were 150 new features. I covered it over a 2.5-hour session, and that is beyond the scope of what we can do today. So let's look at some of the key features. The first one to be talked about is the private methods in interfaces. Interfaces were supposed to be public. They were supposed to be a contractual body of method signatures without any kind of implementation on it. Java 8 introduced default methods. And now we have methods that are both static and default available on interfaces, right? You cannot have private default methods because a default method is something that is inheritable within your child classes or implementations of the interface. And this is useful because you can now add new behavior to existing interfaces without destroying existing implementations. A private default prohibits you from doing that, so it is not a valid combination. Similarly, a private abstract does not make sense because if you create an abstract method and privatize it, no one can see it, therefore override it. So those are not valid combinations, but there are several combinations we look at on the next slide, right? It was originally put up as an experimental feature in Java 8, but it was dropped because there was some amount of discussions on some bugs that were raised, and there's a bug link that I've included below, which can give you some more information. Once again, I have a write-up on my blog, which goes into more detail about private interface methods. Now, Java's support for private method interfaces has been growing, as you can notice. In Java 7, you can create constants and abstract methods, which was typical until Java 7. That's what an interface was useful for. In Java 8, we added default methods and public static methods to interfaces. Going Java 8 onwards, you could now create default methods that could be immediately consumed by current implementations of the interface without there being a change in the contract. So that was a very big benefit. In fact, lambdas and closures and the new collections APIs depended upon these default methods. Starting Java 9, you now have private methods in interfaces and private static methods in interfaces. A private method is something that has logic that is shared by one or more default methods or one or more abstract methods. And private static methods likewise are shared by public static methods. So it was an additional, layer or syntactical benefit that you got by creating private methods and private static methods in interfaces. Great. The next one, I guess, since a lot of this crowd is from the Kotlin Hyderabad, you're probably familiar with Kotlin, and you probably have these methods already available in Kotlin. We now have a list.off. I think the similar implementation in Kotlin is list.off method. It's an infix method that is available on Kotlin. The equivalent in Java now, since Java 9, is the list.off method. And then there's also a map.off method, which can take a key and a value, right? It is similar to a map.off in Kotlin, but the only difference being that there is no to keyword that maps a key to a value in case of a Java 9 equivalent of the same thing. There is a JEP associated with it. A JEP is basically a Java enhancement proposal. So every time a change is made to the Java language or the virtual machine, it requires creation of a JEP. And a JEP is something that is proposed, discussed upon where it should fit into Java, and once it is agreed upon, work is done, and that code is committed into the JDK, source control systems. We'll talk about source control systems later, but understand that this is the JEP process. There is, in addition, at this moment, I'll take a brief segue and mention that there is also a JSR, a Java specification request, right? While a JEP is a task, a JSR can be made akin to a story. So it is basically, if going into the agile philosophy, a JEP is a task that is performed and code can be committed against it, whereas a JSR is a broad overview of something being added or removed from Java, right? So be aware of these two terms as we progress. There's also an amazing blog that was created for the collections refuel at oracle.com, and I have made a link made available in this here. Next, one of my favorite topics to talk about is garbage collection. If people in JAG Hyderabad would probably be very aware, I've done this before. And here we're talking about G1GC, which was first introduced in Java 7 and targeted for Java 8. And due to some bugs, it was actually removed from Java 8 or deprecated in Java 8. G1GC, I have a whole presentation on this, is basically now uses metaspace instead of firmgen, which is an amazing feature because now you can emulate Java programs to look very much similar to any other program that runs on your computer. It can avail of the memory that is available on your operating device. Now, this GC, the G1GC, focuses on garbage-heavy regions and therefore is very powerful in that it speeds up your garbage collection cycle. The JEP for it is included. It is JEP 248. And there's documentation made available both in forms of my presentation and also from Oracle, which has a very amazing list of why G1GC was introduced, what the benefits are, and what they were trying to achieve. Great. Now, one of the things that is very commonly shared as a frustration among Java developers who are looking at versions and need to upgrade Java is the version of Java. It has been a hodgepodge between, patch releases, security upgrades, and so on and so forth. And these caused a lot of issues. Now, in Java 9, there was a proposal to make a change to replace this confusing mix of versions and build numbers and replace it with something simpler, right? But they could not agree upon a decision on what to do was the best thing. Therefore, a temporary solution was provided in the version scheme where you now have a major.minor.security patch as your version streams. So before Java 9, so let us say Java 8, you would have something like 8U261_B12. And you would not know if this was better than 8U251_B25. Which one is better? You don't know. But with this new version, what they've done is you've actually got a number that is easily ascending whenever there is a change made. So you know what is going on and you know that you're getting the latest version. And this JEP is marked as 223. And there is an amazing blog by Mark Reinhold, the chief architect of Java, which says forward faster, which proposed this idea of creating a temporary version scheme. The next is JShell API. JShell API is, if for those of you who are familiar with other languages that have REPLs, which is read, eval, print loops, it's a transcript evaluation mechanism. It's a great teaching tool. It was originally targeted for Java 7. But Java 7, the release of JShell was an embedded JShell without any kind of API backing it. So it was revamped and released in Java 9 with an API. And the JEP for it is JEP 222. There's an amazing JShell tutorial that I would recommend. It's at openjdk.java.net, and the link is included in the slide. And these slides will be made available afterwards, so please feel free to refer to it after. I guess the biggest change that came about in Java 9, which a lot of people have mixed feelings about, is the Java platform modularity system. Now, I'm going to break this over 4 or 5 slides, so bear with me when I go through this. This is probably the longest set of slides on a single topic that we will have. Now, the JPMS was intended to reduce the large and growing Java package size. I mean, everybody kept adding features to Java. So every release of Java, new features came in, and Java just kept becoming longer, bigger and bigger. So it has now reached a point where my first version, I still remember, and I'm dating myself. Uh, the first release of Java, I could carry around on a quarter-inch floppy disk, right? And now I have to think about whether I should get myself a CD or a DVD in order to, I guess, copy Java into a storable format. It's become huge. Now, the intent was to reduce and modularize Java into smaller units, right? And also to remove some things that are no longer used. I don't know how many of you are aware, but there is now a clean separation between Java, the standard edition, and something known as the enterprise edition, which was originally a part of Java itself, known as Java EE or J2EE, and has now been moved out as a separate independent unit, not associated with Java, but called Jakarta EE, and maintained at a different location known as Eclipse Foundation, right? So there's now a separation, and therefore anything that pertained to just J2EE can now be removed out of the Java Standard Edition and either moved on to the Jakarta EE or completely discarded because something better has been written there. Now, when we did this, the first thing to do was to create what is known as a core or a base module, which everybody can depend on. So your object, your Java lang, and something that is commonly used and shared, such as your collections utilities, etc., reside in what is called the java.base module. So this is the base module that everybody should link up to. Each of the dependencies is packed as a JMod file, and we'll talk about that in the next few slides. And instead of there being a class path, as many of you are familiar with in Java, there is now an additional module path. And I'll show you where both of them can function together. Here is how, I mean, this is a very busy picture, but you have to understand there was so much content in Java that you had to actually go ahead and create so many different modules. Now you notice at the bottom of the screen, there is java.base. That is your base module. And then let's take an example of Java SEEE. Those are your enterprise edition packages that still reside in Java, right? So for that to work, your Java base first is used by java.xml, which is used by java.sql, which uses java.sql.rowset, which is a new module in itself, which uses java.se, which uses java.se.ee. So now that you've built a chain of modules, so if you ever wanted to use, let us say, and let's going back to the picture, if you ever wanted to use Java SEEE, the enterprise edition, you know you're getting a module of SE, you know you're getting a module of rowset, SQL, XML, and Java base, so on and so forth, right? If you wanted to use, say, Java desktop, you know that you're depending upon some features, and you'll eventually end up depending upon java.se. So that is how the whole thing is set up, where you can determine which modules you actually want, and now you can create your own JDK executable binary. And let's take a look at that. So when Java was broken down into modules, Java 9 itself became a modular system, right? And it restructures the JDK and the JRE runtime images. So for a lot of you familiar with Java 8, Java 9 onwards, there is no separate JRE. In fact, there is no need for a JRE, and let's take a look at why. There is no more a rt.jar, which RT stands for runtime. So there is no more need for a runtime.jar and a tools.jar under the libs in the JDK distribution. It enables what is called creation of compact profiles, and there is a JEP associated with it. A compact profile is where you determine what you need and you create an executable binary with exactly those modules. So now you are in control of creating your own JRE, right? And that is a very big change. So enterprises may actually choose to create their own format of distributables within their organization or even outside if the licenses permit. And they are free to create something that is extremely tiny and gets the job done. They don't have to depend upon a vendor to provide them a standard JRE that is shared across the entire landscape, right? And that's a huge benefit. Your JRE is very specific to what you do and may include your own modules, right? Maybe you're distributing modules that you yourself have. And those are an immense benefit to someone who now doesn't have to package a JRE and their own modules and tell people to put this in a certain location in order for the application to work. This is done through something called JLink. JLink is a new executable made available, and it has a small script. It is very similar to, if you remember, the C or the C++, it's a linker. So what it does is it links together all your modules and creates a runtime image. And this image is not something like a Docker image, it is just another name for a runtime binary. So do not confuse this with a Docker image yet. There are several JEPs, and there is also a JSR, and there is also a complete spec written for JPMS. The JSR, as I mentioned, is an overarching story in the agile world, and the JEP is essentially one of the tasks that you perform in order to deliver on that story. There are several JEPs associated with JPMS, and it is usually considered very confusing a topic by most developers who start. But if you were to go through these steps yourself, you will notice that this is actually quite simple. And once you practice a bit, you will get the hang of it. And there are a lot of coding katas and solutions out there that help you understand how JPMS can benefit you and how it is not that complex a system. So I highly recommend that you go through that and please share and ask questions if you have any about that. Now, the format is once I'm done with Java 9, I'm going to leave you a room for at least one or two questions, and then I'll move to Java 10. If that format works for everybody, great. Otherwise, at the end of the session, we can have a more thorough question and answer, right? Other important enhancements that I wanted to talk about were java.util.optional. Those of you coming in from the Kotlin world, java.util.optional is very similar to the question mark that you put in a var declaration. So you're specifying that something is nullable or not. And an optional gives you the same kind of feature where you can either choose to use the value if it exists or perform some other action if it does not. And that's the Java equivalent of the question mark operator in Kotlin. There are new methods on the stream. There are new concurrent APIs made available, which is, of course, commonly shared between Java and Kotlin. Compact strings is something that was introduced, which is quite an amazing feature when it comes to performance. Strings are your number one performance hassle in Java, and compact strings aims to sort of reduce that problem. Deprecation API has been improved. So when you deprecate something in that you want to remove something from your JDK, now you have two flags associated with it. There is a for removal flag, which implies that this particular API will be removed. It is not just deprecated, it will be removed soon. So it's a warning. And then a since basically tells you when it was initially marked for deprecation. So it is more informational about when something was marked as informational and that it will potentially be removed soon, right? And then there is a new compiler flag called -- release. So those of you who've operated with Java, you probably know that if you use any build system, you have to provide for a source version and a target version if you're not using the latest, right? And now there is a new flag called -- release that does both and does a bit more, right? It not only sets your class path, it also sets your boot class path. So it replaces three different flags at the same time. And it's a convenience operator, and it is great. You can still use the old mechanism, but you also have a new mechanism of doing things. So with that, I'm going to look for any questions. If there are no questions, I'd like to move into Java 10. And let me know, I guess, Chaitanya or Raj, if you can tell me if there are questions out there.
Yes, Chandra, we do have one question.
Please.
It is from Srinu. He is working on Java 8. So, and he is also using services. He's asking us to suggest some good Java version which is compatible with all the features.
Yeah, so it is always optimal to go to the latest version of Java. Now, this is a great question, Srinu. Thank you. But I also have unfortunately, I don't want to do a shameless plug, but I also have a presentation on choosing your Java vendor and version strategy. So I'll share a link. It is on my speaker deck. If you go to my blog, you will find a link to my speaker deck there. And I'll also share it in the YouTube chat after the presentation. But you have to go through a process of evaluating what you need and why you need it, right? It is not as simple as, hey, use this version, this is the best. Sometimes you want to stick to long-term support releases. Sometimes you want the latest bleeding edge version. Sometimes you want to use Oracle Java. Sometimes maybe you want to just use OpenJDK. Or maybe you want to use some other vendor product, right? So a lot depends upon what your use case is, how much money you're putting towards it, are you doing it for yourself or your company, etc. But those are choices you will have to evaluate, and there's a certain amount of I guess evaluation process that you have to go through to make that determination. I don't know if that answers your question, Srinu.
Chandra, we do have another question
Yep.
from Anji. He's asking us how to get used to JPMS. I mean, learn and practice and use effectively. I couldn't get real-time use cases. Could you please help me on this?
Absolutely, yes. Great question. Although I cannot directly help you, what I can tell you is the hump you're facing is not, you're not alone there, right? I went through this myself. I am sure many of the people on the call would have gone through something similar. But the only thing is practice, right? Create a small library, make it two module library, right? One module that has, let us say, a common set of features, and the other that has your business logic in it, and then try to modularize it. Unless you actually try it out yourself, the chances that you read about it and understand it are very, very low. You have to attempt it. You have to do it yourself once or twice. You'll get the hang of it. And even after once or twice, trust me, there are roadblocks, right? It takes about 5 or 6 iterations of you doing this until you get familiar and you're like, I missed this all my life. Maybe this was how everything should have been. So it takes some time to get there. Don't be discouraged. Do it and repeat it. And once you've seen the success, you will automatically understand how useful this feature is. So it'll take some time.
Yeah.
I don't know if I answered your question, Anji.
Yeah, we have another question. Please share some articles on how to build a custom JRE using Java 9 features.
Okay, I do believe there is a link I included here. And if it is not, you should take a look at the compact profiles, which gives you a lot more information on this. In fact, that is exactly what compact profiles does. So JEP 161. In fact, if you are on a computer right now, you could just type in JEP space 161 in your favorite search engine, and it should land you on that page. Thank you, Savik.
That's it from for now.
Great. So now let's talk about Java 10, and the hashtag associated with Java 10 is works when on Java 10. Right? And once again, this is something that was put up by somebody on the internet. So it's not like an official hashtag, but this is what is commonly used. Great. It was released in March of 2018. It is the first release in the 6th month. It is marked as a feature release, not an LTS, right? So that is something important. So we talked about LTS being a every 3-year release that is supported for a long term by almost all the vendors. And the feature release is typically supported for 6 months, right? After 6 months, typically most vendors drop support for it, but there are some vendors who may choose to support it as long or even longer than the long-term support. It's a suggestion that it is supported for at least 6 months. But beyond that, it is up to a vendor to determine how much longer they want to support. And I'm reiterating that statement because there are certain vendors who support feature releases as long as they support long-term support releases. And it's fine, but the minimum is 6 months. And the general expectation is after 6 months, there is no normal support available for it. So Java 10 was introduced, right? In Java 10, the first feature that I wanted to talk about is LVTI, local variable type inference. This was the introduction of a var as a variable type. Now, var in case of Java is...
I'm sorry to interrupt in between. Your voice is coming as muffled.
Oh,
Yeah.
is this any better?
Yes.
Great. So in Java 10, and my apologies for the muffled voice. So let's go back to the talk. Now, in Java 10, LVTI was introduced. LVTI is local variable type inference. This was deemed as the introduction of var in Java. Now, vars in Java are not like vars in, say, Kotlin or Ruby. They have a different, purpose. Vars in Kotlin, for example, are used as variables. Vals are used as finals or something similar constants. A var in Java is basically a replacement for the declaration, right? And here, for example, in the examples we included, you create a new array list of string and we create a var list. And the var here is going to be inferred as an array list of string for you. So you've just shifted the declaration from the left-hand side to the right-hand side. And in case of the second example, it is inferred. So I create a list.stream, and we know that the list.stream produces a stream of whatever data type you're using, and it is inferred and a var is created. Now, why is it string? Because the list probably itself is a string, right? So it is not like it is magically inferring string here. I'm copying off of the first example where I created the list of string, and my list.stream therefore is inferred as stream.stream. So a lot depends upon the generics, but there is inference of what that variable is, and it replaces whatever that content is. Now, the biggest question is, why do I need this? The answer is, well, it improves readability. If your declaration is so obvious that you know exactly what it is going to look like, why do you bother repeating it? Was the only justification why, for which var was introduced. So it's a readability syntax sugar. It is nothing more than that. And I just want you to take it at that piece value. A var improves readability. Now, should I use var? The jury is still out. So I personally don't prefer using var because I like my the reader of my code to be in full awareness of what I am doing. But then there are situations where the choice is so obvious and the class type name is so large that a var may actually help me improve readability, and that's where I would use a var. That is me. Your options could be different, so you have to choose what works for you, right? And vars have some rules. It requires initialization of the variable. So you cannot have an empty or a null var. And let's take a look at that. So there are incorrect examples. All of these are incorrect examples. Okay, you cannot declare a var without an assignment. It cannot be inferred, so that is illegal. You cannot create an empty lambda var. This is impossible because you cannot infer the type of what f is. You cannot create a null var. You cannot understand what a null means. This is quite a significant difference from Kotlin, where if you were to declare a var and put a question mark, you can actually make it null, right? Although Kotlin does not exactly support nullability and null references, but something similar to this, where some value would result in a null, is possible. And then you have var k, which is just a list of two elements. You don't know if it's an integer, you don't know if it's a long, you don't know what it is standing for. So you cannot actually create it as an array or a set or whatever. So it cannot be inferred. And last but not the least, you cannot use vars in lambdas as method references or whatever, right? And this is not supported in Java 10. And this is marked in orange because it was later on fixed in a later version of Java. So let's take a look at that, right? We'll take a look at that when we get to Java 12. So bear with me until we get there. Now, one of the coolest features that was introduced that a lot of people probably miss or don't understand very well is application class data sharing. Now, this is an amazing feature. When you start up your Java application, it uses what is called CDS, class data sharing, which has been there since Java 5, which was very useful in speeding up Java. So instead of it loading every class in the rt.jar into memory that it needs, it would actually, at shutting down, take a snapshot of what classes you normally use and save them in a serialized format. And when you restart your application, it would load the Java classes from that snapshot. So from a memory snapshot of what was in memory before, and use that to start up your JVM. So it used to speed up your JDK very quickly. In fact, that is how JDK speeds became akin to C Sharp or C++ speeds. Now, this was great. Now you can also do this with your application. So it is not just the Java classes, your application classes are also brought into memory using a similar snapshot. But for this to happen, you need to actually set a flag called use app CDS, right? But this was a very helpful feature for applications that were experiencing slow startup times because they were loading a lot of classes. So you can now create your snapshot of, hey, these are the classes I want to load every time my application starts. And this is very slow. So create a snapshot of it and let me have at it every time my JVM starts. Now, another feature that was introduced, which I'm a big fan of, is creation of an experimental. So this is experimental Java-based JIT compiler. Now, a Java-based JIT compiler or just-in-time compiler is basically a separation of your compiler from your JVM. So instead of a compiler being embedded in your JVM, it is now stubbed with an interface and there is an implementation associated with it. So it was a clean separation or a decoupling of the compiler from the JVM. So now you can replace the compilers, which allowed the creation of a Graal VM ahead of time JIT compiler and several other compilers, right? Azul has one, OpenJDK has one, OpenJ9, etc. There are several new compilers that exist because of this one cool feature. You can create your own compiler because it is now an interface. I don't advise you to do it, but if you wanted to, yes, you can. And as long as you comply with the spec and use the use JVM CI compiler and provide your compiler name, you are free to use whatever compiler you want on your JVM. That is amazing a feature. In fact, a lot of new technologies have come out just because of this. And this is based on what is known as a Project Metropolis. So this is something you should totally look up. And there is an announcement for Project Metropolis, which was created in 2017 September. And this is a great read. It's a news article. It's a BBS kind of a mechanism where there are threads of mails exchanged. But it is an amazing read. So if you find the time, please do go review this. Now, we talked about this in Java 9, where there was a time-based release versioning, right? There was some versioning that they introduced where there was a 3 format. You had a major.minor.security patch, and that was marked as temporary. So by Java 10, everybody had agreed upon a versioning standard. And the new versioning standard was going to be a 4 decimal feature. So you have a feature, which is your Java version typically, the interim version. So is it, let us say, 10.0, 10.1, which would imply a minor update. An update, which is basically, are you providing an update to the JDK itself? And a patch. So now a patch is a subset of an update. So you can actually very clearly put releases in an ascending or descending order or sort them otherwise because you have a version scheme that is fully numeric and dot separated. In addition, it provides for a new system property called java.version.date. So not only do you use your version, you can also programmatically determine if a version of Java is ahead or below what you're using. So it is amazing a feature both in terms of programming logic as well as in simple command line or terminal logic where you can determine what version of Java is the latest, right? And there is a JEP associated with it. Obviously, I'm not going to go into a lot of detail about this because it's very easy to understand what it has done. There are a lot of other features that were introduced in 10. A few among them was alongside a JVM collector interface, a garbage collector interface was introduced. A garbage collector interface does the same thing for Java as the JVM CI does for the compiler, right? Now you can create more garbage collectors, any number of garbage collectors, as long as they comply with the spec. They're just implementations of an interface, and you can plug in any GC that you want by using ++x use GC, and we'll take a look at it shortly, and say use your particular garbage collector. So you are now free to write your own garbage collector. I would once again advise you not to do it, but if you so intend to, you have that available. Now, I'm going to break for questions. Does anyone have any questions about Java 10?
As of now, we don't have any questions.
Great, thank you.
Yeah.
Java 11 was a long-term support release. It was introduced in September of 2018. Again, you can find a lot of features about Java 9 on the OpenJDK site. And the OpenJDK is very interesting for those of you who may have been hearing me for the past few minutes, is that people get confused between Oracle JDK and OpenJDK, right? So let us make that very clear now. Oracle JDK is a vendor product. OpenJDK is a reference implementation that is owned by every single vendor. Okay, so it's a reference implementation. It means that it should ideally not be used in production if you want commercial support. But what it does is it provides for a reference implementation that every vendor can take, right? So it is something that is hosted and stewarded by Oracle for the first 6 months. So every 6 months, when a new release comes out, let us say in March, until September of the same year, Oracle will actually steward or lead the effort on that OpenJDK. And after the 6 months, someone else, any other vendor other than Oracle, will pick up and lead it. Now, the code is hosted on Oracle servers, okay, but it is not an Oracle product. So OpenJDK is something owned by the world. It is technically the freest version of Java you can get because no single person owns it. You're free to download OpenJDK and use it. Now, the chances are if you're using it in a commercial establishment, you're probably not getting commercial support for it. So you should probably choose a vendor who rebuilds the OpenJDK with a different, set of support matrix made available to you. But OpenJDK is free. So if you ever wanted to experiment on a new version of Java, OpenJDK is probably your first bet. Great. With that distinction, let's move into Java 11, which is the first long-term support release we are looking at. So we talked about this when we talked in Java 10, is that local variable syntax did not apply to lambdas, right? So you were not able to do this in Java 10. And in Java 11, the first fix they made was to make sure that it was available, because there was a lot of hue and cry. Everybody asked for this feature. And the justification was, hey, I want to use annotations. And if I don't put any kind of variability or signatures in there, I am unable to put annotations on it, right? So if I can't put annotations, for example, most people will simply say X comma Y and then call a lambda on it. Sometimes you want to be able to add annotations, but if you don't put some sort of a declaration, you cannot add an annotation on it, which is why vars come in. And now you can actually support that using creation of a var X and adding an annotation to it, a var Y and an annotation to it, and therefore call the lambda. So this was the use case, and it was definitely satisfied and produced as a part of Java 11. Now, this was maybe not very significant for a lot of people, but the people who were asking for it were very happy that this finally came out, because it brought about a consistency to using var where they wanted it most. One of the key features introduced in Java 11 was the ability to launch single file source code programs. This is very similar to how you in Ruby or Kotlin have scripts that you can simply run. Java does not have a scripting in itself. JavaScript is now completely different, a beast. But what Java now supports is if you write a single class, Java, right? If you write a single .java file with one or more classes with exactly one public class, then you can actually simply call Java hello world.java, right? There is no javac. You simply call Java on a Java file. It actually compiles the code for you and runs it at the same time. So it reduces the overhead of you having to remember to compile and then run. Why do you need this? This is not for typical Java programmers, but it is a great tool for students and new beginners. And this was one of the biggest problems with Java. Existing developers use Java freely, but no one could enter freely, right? They were getting confused with so many instructions, and reducing the instruction set by simplifying or I guess amalgamating operations felt like a very logical thought process, and that was introduced. You may have noticed, right? Even in prior versions, we talked about JShell API, we talked about single file source code programs. There's a lot being done for lowering the entry point into Java alongside adding new enhancements. It's a fine balancing act for the architects as the JVM and Java. They have to actually choose to both please existing developers and make it easy for new developers to come in. And they're doing this tightrope walk themselves. So I'm very appreciative of that, and so should you. Now, we talked about this when we first covered modules, is that there are modules that are vestigial or not required anymore by Java itself. Because it's a standard edition, there is no more EE in the Java itself. So there is now a all-out push and drive to remove modules that are no longer required in Java. So Java EE and Corba modules, Corba, I don't know how many of you remember Corba, I do, has now been deprecated from Java 9. Deprecation does not mean removal, it means mark for removal. The source code will be deleted from the OpenJDK repository, which means they're really going to be deleted. The binaries do not include these deleted modules, right? And then there is a separation of Java SE and Jakarta E that we already covered, which is one of the intents behind which this was actually made, this deprecation was made possible. And so that is being highlighted in a JEP 320. One of the coolest garbage collectors, and I don't know how many of you know me, but if you have heard me talk at JAG Hyderabad or at other places, I talk a lot about garbage collection. Now, one of the coolest garbage collectors that was introduced as an experimental feature, notice the E up top, is an epsilon garbage collector. An epsilon garbage collector is one that does not do anything, right? It is a do-nothing garbage collector. And the immediate question is, why do I need a garbage collector that does nothing? Well, it has a lot of benefits. You can do performance testing of your application. Most of the time, what happens is if you run a performance test on a regular JVM, your GC is kicking in and altering your performance outputs. So you don't know how well you are doing as an application, because maybe the GC is compensating for your failures by going into overdrive and evicting objects that it should much faster than it should, right? And those are things that you can quickly find out by using a no-op garbage collector. It is great for memory pressure testing, how much of your memory is consumed by your application. It is great for extremely short-lived jobs that don't need a garbage collector. If you don't need it, why even bother with it? And it is also used for deeper JVM development where you don't want the focus of the garbage collector. Sometimes your JVM, your garbage collector does some amount of marking of objects, right? So it dirties the objects. You may not be aware of it as normal Java developers, but if you're a JVM developer, you're very well associated with it. And Epsilon can actually avoid those things, and therefore you can focus exactly on a clean object and do some other operations. Now, it's a very interesting garbage collector, and you should definitely focus on the JEP 318 if you want to learn more about this. Another new garbage collector introduced was the Z garbage collector. Z is an amazing garbage collector. Again, it was introduced as experimental, and it has extremely low pause times. If you know garbage collections, you know that it pauses your application when it performs garbage collection and cleans up your memory, right? Now with Z garbage collector, there is a pause time that is guaranteed of a certain duration. So it is not like any regular garbage collector, which will take whatever time it needs. Z actually focuses on chunked time slots of, let us say, 10 milliseconds or lesser, and cleans up whatever garbage it can, and then it moves to the next block and cleans up 10 milliseconds again. So it is guaranteed pause times, which makes it very predictable, right? And it can handle a range of small or large memory footprints. We'll talk about more about this when it becomes regular rather than an experimental feature. And it is a foundation for newer garbage collection mechanisms. It's a concurrent garbage collector, it's a single generation garbage collector, etc. I won't go into more details, but there is a JEP associated with it. So please do take a look at the JEP if you're interested in knowing more about Z garbage collector. Other features introduced was nest-based access control, which I'm not going to cover deeply. Class constants, there's a new constants API. There's a new HTTP client, and then there's a Unicode 10 introduction in Java 11. There are more features. Java Flight Recorder is now made available. So it has now moved into a public domain. OpenJDK has it. Oracle no longer owns Flight Recorder. TLS Security 1.3 was introduced. Nashorn JavaScript engine has been deprecated. So there is no more JavaScript engine in Java again. And this is basically because now the focus is on GraalVM to do, the polyglot support and not Java itself. So with that, we come to Java 12. Again, I'm going to take a quick look at if there are any questions.
Chandra, we don't have questions right now. Yeah, you can move.
Okay, great. Thank you.
Yeah.
How are we doing on time? We're good?
Yes, we still have time.
Okay, great.
We do have 40 minutes of time. You can
great. Perfect. So let's take a look at Java 12. It was introduced in March of 2019, obviously 6 months after Java 11 was. It is a feature release, not an LTS. And here's a link to where you can find out more information about Java 12. First thing that we want to talk about in Java 12 was a preview feature. Now, in the past, we talked about experimental features. This is a preview feature. I told you about the difference between the two, but I'll again repeat it. An experimental feature is one which may be dropped finally because it was not useful in experiment. A preview feature is something that will eventually make it into Java, but is being introduced with the hope and aim that someone will give you feedback to improve it. Right? So a preview feature is something that is intended to make it into the ecosystem. An experimental is something that is added with no obvious intent of adding it if it fails. It's experimental. So there is a big difference between the two. This is a preview feature, which means switch expressions would undergo a change and it would be available in Java at a future state. But for now, there is a mechanism to do previews. You are used to switch cases in the past, and for those of you who are not, it basically provides for a control flow mechanism based upon the value of a certain variable, right? So based upon that variable, you can switch on that variable and you can create cases. And with cases, you actually write some logic and then you have to break the case, so you break out of the control flow. If you do not break the case, the subsequent case will also get executed. And that was something that Java developers over a period of time learned to understand and have been working with Some developers still make mistakes with it, and then they find out painfully that they made a mistake in a switch case logic. It is common. But with Java 12, what changed was an introduction of a new arrow variable, similar to a lambda syntax. So here, what we're doing is in a main method, I have the month specified as September, and I'm doing a switch case on the month variable. And in case of January, February, and March, I declare the quarter as first quarter, April, May, June, it is second quarter, and so on. So September should result in Q3. And the only change you notice is there is no more a need for a break statement. I use an arrow syntax, which means it is actually it is producing a value that can be assigned to another variable, which was not possible in earlier versions of Java switch cases. Obviously, Kotlin has support for something like this for a long time, but Java did not. And now I have the ability to actually assign the output of a switch operation into a variable. Now, I don't need a break because this is almost like a return statement, right? So this was what was introduced in Java 12 as a preview feature. And this made a lot of sense because now I can do assignment from a switch case without having to individually say case Jan, Feb, March, and then write a complex block that says quarter equal to 1 or quarter equal to 2, etc. And then at the end, if quarter not equal to null or something like that, I perform an operation. That's no longer required. The JEP for this is JEP 325. It is listed down below. Please do take a look at it. Next comes compact number formatting. Now this is useful, but I don't know how many of you actually have used this. This existed in Java as a helper utility through some common slang or similar operations. But now I can specify number formats, and I can do what is called a compact number instance for the given locale as short or long, right? When I do short, it basically, converts it into a K or an M or whatever, and it reduces the number of decimal places based upon what fraction digits I set. In here, I set the impressions to have a maximum fraction digits of 1. If you look at the bottom of the highlighted area, it sets the maximum fraction digits as 1. So I get 76.1K on the number 76092 as indicated in the center of the highlight. Right, so impressions format 76 shows up as 76.1K, right? And in case of a longer format, right, if I were to use what is called the long format as in the center of this highlight, and I set the maximum fraction digits to 2, I can get 2.01 thousand as my text when I pass in 2011 as my input. So it provides for a more readable English-like number formatting scheme, and this is quite useful. I mean, especially if you're into social media and stuff like that, you will notice something like this show up. And in fact, just FYI, Twitter uses this. Twitter runs on JVM. They use Graal, not Graal VM. We'll talk about that if time permits. But yeah, they use this feature quite heavily, right? And so are many other people using this. Another garbage collector was introduced in Java 12. This is Shenandoah. So you've heard of ZGC, you've heard of G1GC, you've heard about Epsilon, and now you have Shenandoah. Shenandoah is a tiny and consistent pause collector. Red Hat created Shenandoah. It's quite an interesting garbage collector. It does some amount of dirtying of your Java object, but it is concurrent in compacting. So it is running pauseless in the sense that the application does not even know that the garbage collector is running. The application is never paused. In fact, it has so minimal a stop the world scenario that you do not even understand that there is a garbage collector happening under the hood while your application is working. So it's an amazing garbage collector in itself. Earlier, we had so many options that we had to tweak on a single garbage collector. And now we have a different problem in that we have so many amazing garbage collectors. We now spend time racking our heads to think about which one should I use. So it's a different problem, but it is definitely a better environment because you have more options on garbage collectors. Shenandoah and ZGC are also very awesome because they reduce the number of flags that you have to set on them. So these are important benefits as a developer because you are more focused on, hey, I want to use this garbage collector because this is my use case, and you're done. You're not setting options and flags to tweak that garbage collector anymore. It has been done for you, right? And that is something very useful for a developer because they have lesser need to focus on the garbage collection. I don't know how many of you test, but if you ever used micro benchmarks, which is where you test individual methods or individual blocks of code, micro benchmarks are amazing for that, but you have to be careful with micro benchmarks. A new suite of micro benchmarks was introduced in Java 12. It eases the addition, build, and running. It creates something very similar to the JVM suite, and that was quite useful for a lot of people who build libraries. So I don't know how many among you build libraries, but if you are, a micro benchmark suite is something that is going to be very useful for you in the near future. Other features, there was a Java Constants API introduced, and then there was default CDS archives introduced. We talked about this earlier. The CDS is basically your class data sharing. So it can now produce default CDSs that are very specific to your use case. So you may choose to use, let us say, Java Base and let us say Java Desktop as your, serialized classes for the default CDS. Someone else may choose some other Java classes as well. So you can create your own default CDS archives. Abortable mix collection for G1. So you can pause your garbage collector if it is taking too long. You can abort it, right? And then you can also return unused committed memory from the G1. So what happens is an object was created and the object was finally garbage collected, but that memory was never returned back to you directly. So you could not use it. But this was committed memory, right? Because someone committed an object to it. Now, this is now possible by you setting a flag saying, hey, if G1, if there is any memory that you find that is committed but empty, return it back so I can use that memory. And that is a new JEP that was created, and it actually helps with situations where you create a lot of objects, and it helps with situations where you have smaller memory constraints. So it's useful to know about this. Any questions on Java 12 before we move to Java 13?
No, Chandra.
Okay,
Any questions?
Okay, the hashtag for Java 13 is all green with Java 13. It was introduced in September of 2019, again, 6 months after Java 12 was. It's marked as a feature release, not an LTS, and its link is included right below. We talked about dynamic CDS archives for a bit, introduced in Java 12. It was introduced as an experimental feature, but dynamic CDS archives made their way into Java 13, which is why I skipped that when we talked about it. It extends the app CDS that was introduced in Java 12 and 11, where your application classes could be loaded dynamically at startup. It extends it to archive app CDS at application exit. So when your application exits, you know what is in memory, and you can actually store those to restart the next time. So not only does it speed up startup times, but it also lets you get back to where you were in your application at a later point in time. CDS and app CDS were static because you had to preset those. You had to actually create those data stores before and or completed the end of the application. Dynamic CDS is an addition to this. So in addition to you having CDS, which is the Java classes, and app CDS, which is your application classes, being stored as snapshots and loaded, a dynamic CDS is going to read your memory at the end of your application and store that state as well. So now you have all three options available. And there is a few flags you have to set in order to get this. One is to archive classes at exit and put them into a JSA file, which is a Java archive. And then you can load that using shared archive file, myJSA, to load them back. So if you set these two values, it would appear that your application never shut down. So let's assume on a Friday night, you shut down your application with running the first flag. And on Monday morning, you restart your application by running the second flag. It is as seamless as Java would not even know that there was a change made to your application. It would continue as if it was continually running all that time. So it's a great feature. Switch expressions underwent a second preview, so a change. Now, this is what was the model I was talking about. Preview features are bound to change. And this is why feature releases or non-long-term support releases can introduce some variability that you should be aware of. And this answers the earlier question, I guess, Anji was asking is, what vendor and version should I use? You make these choices based upon, hey, do I depend on features that are bound to change? Then I'm okay with a feature release. Do I need features to be constant and never change? then I will stick with long-term support releases. That's one of the decision-making points that you should consider. Great. With the second switch expression preview, what was added was, instead of an arrow-based syntax, now you have something called the yield operator. A yield is a new operator introduced in Java, which basically allows you to yield back the same result. The benefits are basically now you can create a complex structure around it, make a method call around it, etc., which an arrow operator did not support. So it was a slightly more improved version of what was supported in, let us say, Java 12. But it is still on a preview mode. It is still ready for changes. So Java 14 may actually change this further. That is something for you to be aware of, right? But this is the second preview. Is there a time limit on how many previews should happen? No. What is the normal preview cycle? Typically, for a new feature introduced in the language, a preview cycle lasts 2 Java versions. At worst, it could go to 3 Java versions, but there is no limit. It could even go to 7, who knows? But there at least have to be 2 preview cycles for some language changes, because they have to give developers enough time to experiment with it. So that is something to be aware of. Text blocks were introduced in Java. Text blocks are amazing for a lot of folk who not just use Java, but use other technologies such as, say, XML or JSON objects or something outside of the Java scope, which is indented. Or YAML. I hate YAML, but yes, or YAML. Now, when they copy paste that content into, let us say, a Java program, they go through a lot of hoops in separating line numbers, introducing new line characters, plussing the strings so that they look readable in Java, etc. All that can be replaced by you simply creating what is called a text block. It is a preview feature, but the preview feature is very similar that you find in, let us say, the Kotlins or the Groovies of the world, where you have a multi-line string, right? This didn't exist in Java. It now exists in Java since Java 13 as a preview feature. Now, whenever I say something is a preview feature, you have to understand, in order for these features to work, you can't simply download, let us say, Java 13 and look for this to work. You actually have to set a flag. Okay, and the flag is enable preview. It says -- enable -preview. You have to turn that on to be able to avail of preview features. This is done because if you were using this in production, if you were using Java 13 in production, you don't want to use a preview feature which would later on not be available to you, right? A preview feature can change. So an enable preview is required. Likewise, an experimental feature requires a use experimental flag to be turned on. Okay, that is something I want you to be aware of. Other features were ZGC was enhanced, and I don't think I'm going to talk further about legacy socket API. It was re-implemented because it was first created in Java 1, and it required a massive amount of change, and that was being changed in Java 13. So I'm going to take a quick break and ask if there are questions. I'll also take a gulp of water.
Chandra, as of now, we don't have any questions. Looking like people are clear with the presentation.
Great, thank you. Okay, so Java 14, and I just don't know how we're doing on time. I guess we still have about 15 minutes or so.
Yes, we do have time. No need to worry about that. Yeah.
Okay, great. So Java 14, it was introduced in March of 2020. Now it's becoming very, I guess, periodic. So every 6 months there is a release. In fact, this was released on my birthday. Yay. And it is marked as a feature release, not an LTS. Java 14 was huge. Believe it or not, there were a lot more features than one could expect in Java 14. First, this was very important for developers, pattern matching. Now, this is syntactic sugar. There is not much it does, right? What it does is, I'll give you a simple example. If you were to write an equals block, you typically get an object. You look for if that object is of instance of a certain object that you are trying to do an equals on. If it is, you cast it into that object, and then you perform some operations on that object. If the object does not match the instance of, you return a false on the equals, right? That was common logic that everybody used. But with Java 14, you now have a pattern matching where I can simply say object instance of string s. So I'm actually declaring s right in that particular condition. And when I do that within the if block, I can use s. So I don't have to cast again, right? And in the else block, there is no s made available because it only is created as a variable if that object is an instance of string. If the object is not an instance of string, there is no s. Now, this simplifies your code. It improves readability, but you have to be careful because a lot of people are used to the syntax of object instance of string, and suddenly they see s and they're like, where did this s come from? So for the first few cycles, maybe just add a comment saying using pattern matching inside the block or wherever. But this is a very useful feature and trims down the amount of code you write repeatedly. So elimination of boilerplate is another feature that Java has been driving constantly towards. You will notice that with var, you will notice that with pattern matching, and you will notice that with a lot of other things that we will talk about in the near future. So the three main things that Java has been focused on is how to make it simpler for Java developers who are currently working on Java, how to make it so that the entry points for new developers are lower, and how to make it such that boilerplate code can be eliminated, right? So those are three things that we've been learning about how Java is progressing, and these are very good benefits. The other thing that was added, which is probably the dreaded nightmare of most Java programmers, and which is where Kotlin developers usually start laughing at Java developers, is null pointer exceptions, right? I have been successfully able to create similar exceptions in Kotlin because I'm a bad programmer. But a common problem that Java programmers face is null pointer exceptions and not being able to understand where it comes from, especially if you have a nested object, right? In this case, you have a.b.c.I equals 99. And if I use this value somewhere, I get a null pointer exception. There is no indicator of what is null. Is A null? Is B null? Is C null? What is going on? But starting Java 14, a preview feature added is basically where I can read the exception stack trace, and it clearly says cannot read field C because A.B is null. So now I clearly know that my culprit is B, and therefore I can go figure out why B is null. So it's a helpful null pointer exception that gives me more detail about where my null pointer exception exists. And this is very useful to debug. Null pointer exceptions are basically the bane of Java developers' programming styles because they usually fail to understand where the null is coming from. A lot of folks still don't use optionals, and usage of optionals is important. And without optionals, I guess null pointer exceptions are very much a possibility, and having these kinds of helpful hints helps. The JEP for that is JEP 358. Please do read more about it if you are interested in this. Now, a lot of you who are not just working in Kotlin or other languages similar, say Haskell or any other language, are very familiar with algebraic data types. Algebraic data types are basically types that are very useful in holder objects and help you with certain kind of logic indecisions. The same has been introduced in Java in terms of records. In the Kotlin world, for example, you probably know these as data classes. They've been introduced in Java as records. They are immutable data objects with built-in constructors, accessors, a toString, equals, and a hash code method built into them. You can also override any of those by creating your own objects. So syntax is very similar to a data class in Kotlin and is quite different from what you write typically in Java. So instead of a class, you now have a record. You give the name of a record and you pass its variables in as parameters. This is also your constructor. So implicitly, a constructor of this type will be created. It'll generate a toString method for you. It'll generate an equals method, and it'll generate two methods known as low and high. Methods known as low and high. So the getters are basically do not have a get prefix. It is just low parentheses and high parentheses, right? So it's very similar to how Kotlin operates there. Now, you will not have setters because these are immutable data objects. There is no mutability associated with records. When you want mutability, you just create a new record. And this is moving towards a more functional style of programming. So immutability is a benefit you get. Once again, this is a preview feature. So please exercise caution when you use records in Java 14. You have to enable preview in order to use this feature. But if you do use it, it's quite an amazing feature. It has a lot of benefits it brings to the table. Obviously, Kotlin developers are quite familiar with records or data classes as they call them there. And this is a feature parity in Java from what Kotlin has. Uh, Other features, I think I skipped some slides somehow. Okay, I think I covered everything in Java 14. Great. ZGC, Legacy Socket API, we covered all this. And now I have a little surprise, but are there any questions?
Yes, Chandra, we do have one question.
Please go ahead.
How is Java addressing using low memory footprint containers, since JVM has been traditionally memory heavy?
Great question. So, with the introduction of new garbage collectors, which are low memory footprint friendly, such as G1, GC, that is one option. Also, JVM has been, since Java 9, has the ability to control the memory and the CPU usage thresholds. So before Java 9, if you use JDK on a container or a Java on a container for that matter, it would not honor the constraints you set. So you could actually say use 0.5 CPU, but guess what? It would use as much CPU as it could when it needed to. Same goes for memory. But with Java 9 onwards, a subtle change was made in the background that is not visible to you. You still use the same syntax that you did, but it now honors your CPU and memory footprints. So both in terms of usage and in terms of its garbage collection, Java has been steadily improving. And from Java 9 onwards, you will notice that low memory footprints are very much possible with Java. In fact, one of the best experiments, and I have another talk on this, is when you do a JVM comparison and just compare, let us say, a Java 8 program with a Java 9 or above program, without you making any change at all, if you rerun that program, you will notice that it runs faster and it takes less memory. And that is something that you get for free without even having to make a single line of change in your code or a single flag change in your code. So I don't know if I answered your question, Souvik, but
Yeah. That's the one question we have right now.
great. So here's a little surprise. Thank you all for attending. Just wanted to let you know that in addition to everything we covered, I have now got a Java 15. Although this was a Java 9 to Java 14, I have something about Java 15. Now this is marked with some amount of flags because, hey, Java 15 has not yet been released. Okay, so take the next few slides with a grain of salt, but this is going to come out potentially soon. Java 15 will be released. It is not yet released in September of 2020. In fact, it will be released on September 15th, 2020. It's marked as a feature release, not LTS. It has many new features, so let's quickly go through them. We talked about algebraic data types, and for Kotlin users here, sealed classes are not new. For Java folk in the audience who have not used Kotlin, the sealed classes are somewhere between, let us say, a fully open class that can be extended anywhere and something that is a final class. A final class means it cannot be extended. A sealed sits somewhere in between there. A sealed determines the number of classes that can extend it. So you limit the number of classes that can extend it using a sealed class or a sealed type for that matter, not just classes. You now have new modifiers called sealed and non-sealed. Non-sealed is basically your default in that if you create a public class XYZ, you can, I guess, extend XYZ any number of classes, and that's what a non-sealed class is. A sealed class in difference is basically where you specify a class and say, hey, I only permit these 5 or 6 classes to extend me, and you declare the names of those classes. So someone implements those in the same package or the same module can actually extend your class and no one else can extend it. So it brings about a limited hierarchy for your class. It's quite an amazing concept, but notice that there is still a preview feature. That is something to be aware of. But the 3 new things that you should be aware of is a sealed class, a non-sealed, and a permits clause. Great. The next, we talked about records in the past. We now have a second preview of records. It extends on the first preview. but it now has the ability to create in-method local records. So within your method, you can declare a record and use it. So it's almost like a tuple creation, right? So it is sort of moving towards a tuple, but it's an immutable tuple. And it clarifies the usage of annotations on records. And the JEP is quite interesting, so please do read that JEP. You now have what is called hidden classes. Now, as soon as you hear hidden classes, do not think encapsulation. This is not anonymous classes. Hidden classes are basically those that have logic that you don't need. So let us take, for example, something like a Spring framework, right? When you use Spring framework, you get dynamic proxies in it. Now, obviously, you can look up the code for the dynamic proxy while you are in your editor, in your IDE, but you shouldn't. Why do you need that logic? What if you start using that logic in your code? Because that can change. What happens to you when they change that, right? So now there is a concept of hidden classes. These classes are loaded to generate what they need to, but no one else can see what is in there. So they provide another meta layer of classes. And these are great for things like dynamic proxies or runtime generated classes. You don't need to see what is generating them. You just need to use the classes that were generated, right? So those classes that support for non-discoverable implementation of classes are called hidden classes. And they are things that can be loaded. And once they do their job, they can be immediately unloaded and no longer required. You never get to use these classes anyways. So these classes provide for another separation layer between what a framework needs to create what you need. And so you don't actually depend on the framework classes at all. And that is a separation that was introduced in Java 15. This is not a preview feature. This is built in. ZGC is no longer experimental now. So I told you about the flag that you use for experimental. Unlock experimental options is no longer required for ZGC. So ZGC is now made available. Now, although ZGC is available, G1GC remains the default garbage collector. G1 is still the normal default garbage collector because ZGC is great for large memory heaps. G1GC still stands out as the best garbage collector for smaller heaps. So it is still left as the default. And that is something I want you to be aware of. So now there are three different choices you have. You can simply use a flag to use ZGC, but G1GC is your default garbage collector in Java. Shenandoah is no longer experimental. So we talked about Shenandoah earlier. Shenandoah is great for pauseless garbage collection. We talked about this earlier. It no longer requires the unlock. You simply say use Shenandoah GC and you're able to use that. Once again, the new JEP for that is included. You also have text blocks, which are out of preview now. So now you can use text blocks starting Java 11. You have a JEP for pattern matching. This is the second preview for that. And then you have some digital signature algorithms and the removal of Nashorn. It was deprecated in the past, it's removed. RMI is deprecated now because it's now a part of EE and not Java SE. And those were some of the features. The legacy datagram socket API was added. This was again since Java 1. It has been the same API. It has now been rewritten or re-implemented. And then there is NUMA or a foreign memory access API, which is in an incubator phase. So it is still beyond experimental. There is another phase called incubator, which is like a feature toggle on the JVM itself. So you may or may not get to see it, right? Solaris and Spark ports are finally being removed. And we are now going into a more standard model of a few form factors for the operating systems. So those were the features I wanted to cover. Thank you so much for patiently listening to what I had to tell you. So if you have any questions, I'm happy to answer them. Chaitanya, I cannot hear you.
Sorry, I was talking in mute. Yeah. So Sovik is asking a question about this. Does Quarkus or Vertex frameworks help address the memory footprint issues?
Yeah, so it depends on what your question exactly is, Sovik. Memory footprint issues are a huge umbrella onto themselves. Are you talking about the memory consumption? Are you talking about startup? What exactly is the nature of your question? Let me move my laptop over so I can Let me just stop sharing and give me a minute. Okay, great. All right, now I have YouTube, so you can type on YouTube as well. The startup, basically, yes, using something like Quarkus helps a lot, right? I guess one of the benefits of using Quarkus is its startup time. And if you really want to avail the benefits of Quarkus, you also want to look at Adopt OpenJDK or Adopt TM as it is called now. That is quite a useful, I guess, JDK, because OpenJ9 has been sort of quite amazing when it comes to startup times. Likewise, GraalVM is quite amazing when it comes to memory footprint issues after you start up. You have to do your experiments on what works best for you, because sometimes faster startups are important. Sometimes memory on volume is important. So you have to make that call by experimenting with various JVMs. But as a default, I mean, I'm happy to refer to you to the slide deck that we presented on comparing JVMs, both in terms of their startup times and their performance using benchmarks. Um, what we found out is a choice between Adopt OpenJDK or GraalVM works in your favor when you want footprint management. When you want performance, you're looking at Azure or Oracle. So make your choices according to that and according to, I guess, both licenses and commerciality of what you're doing, and you will know what you want. Don't know if I answered your question, but let me know.
Yeah. We have another question from Andrews. Do you recommend Java 14 for the production?
It depends. There is no answer yes or no, right? I did start off with this comment when we talked about feature and long-term support releases. A lot depends upon, are you comfortable with either usage of preview features or with language changes over the subsequent releases. If you are not, you could use Java 14. I'm sorry, if you are, you could use Java 14. In addition, after 6 months of Java 14 release, which is September 15th, commercial support by most vendors will disappear. So if you are okay with that and you're just going to experiment with features and put it in production or support it yourself, if you have a Java engineering group where you work, or if you're going to do your own Java engineering at home, you should absolutely use Java 14. The way I work with this is I basically have Java 14 installed and or 15 installed, and I will run that myself and I'll learn the new features. But in production, I stick to using long-term support releases that have some vendor support for.
And Pawan Jain is trying to ask about RMI activation. I think the only RMI activation is removed, and rest of the RMI is going to be supported. Is it correct?
Yes, that is a correct statement. And in fact, if you can go back in my slide real quick. I already stopped sharing screen. Yeah. So RMI activation is going to be removed. RMI will be marked for deprecation, right? It is not yet deprecated.
Guys, if you have any other questions, please feel free to post in chat.
Looks like there are no further questions. If there are questions, please do ask. Otherwise, we can definitely return back some of your time. I know it's evening there. Definitely, you do want to get back to your own regularly scheduled programming. But please do feel free to reach out to me even after this. If you have any questions, I'm happy to answer them. And of course, I will be sharing the deck with Chaitanya and Raj, who can further propagate it to you by any means that they choose fit. With that, thank you so much for attending and thank you for the great questions. I look forward to, I guess, talking to you sometime soon. Have a great evening.
Thank you very much, Chandra, for being with us today. It's a really nice, informative session. Got to know about many JEPs. Basically, if I go through the blogs, they only highlight some of the features, but you highlighted details detailedly. That's a good informative session for us. Thank you very much.
Thank you for attending, and thank you for hosting. I'm very grateful to Kotlin Hyderabad and Jag Hyderabad for hosting this session, and thank you all for attending today. Have a great evening.
Yeah. With that, guys, if you want to give any presentation, please feel free to contact us. All the links are available below the description, and also our meetup page is equipped with all the links. Also, we will share the deck and links after the presentation in the meetup group and as well as in the description. So please be join with us, and I hope we'll see you in the future sessions as well. Thank you very much, guys, for joining us, and be safe, maintain social distance, and have a nice weekend. Thank you very much. Bye bye.